Welcome back, everybody. We are looking at example 1 on page 101 of the workbook. And this is our first example of using the fundamental theorem of calculus to calculate an integral. Okay, in particular, we'd like to calculate the integral from 0 to 1 of 2x dx. Okay, so let's remind ourselves of what the fundamental theorem of calculus says. We kind of talked through that in the last video. Basically, the fundamental theorem of calculus gave us a way to calculate an integral provided that we can find an antiderivative for a function. It looked like this. So if we want to integrate a function that looks like little f of x, we need to find an antiderivative of that function and do this calculation that we see over on the right-hand side. Okay, and an antiderivative is really just the opposite of a derivative. So let's jump back down to our problem here and see if we can talk through this. So the function that we're trying to integrate is 2x, okay? We're looking for an antiderivative of that function, which we're going to call capital F of x. And to find an antiderivative, you can answer that question by asking yourself, can you think of a function whose derivative would get you back to 2x? Okay, so we're looking for a function whose derivative equals 2x. If you think about that for a minute, you might come up with the function x squared. That is an antiderivative of 2x because, here's how we would check that. The derivative of x squared is indeed equal to 2x. Okay, well, because that's true, then the fundamental theorem of calculus at the top of the page tells us the following. Namely, that the integral from 0 to 1 of 2x dx should be the antiderivative evaluated at 1 minus the antiderivative evaluated at 0. We're just really writing down what the fundamental theorem of calculus tells us. Okay, well, how would we do this calculation? We know what f of x, capital F of x is. It's sitting up here, so really all we have to do is substitute in 1 and 0. So capital F of 1 would be 1 squared, and capital F of 0 would be 0 squared, and we're going to get an answer of 1. Okay, that should be the value of this integral if we've done everything correctly. Just to reassure ourselves, let's check that answer graphically. Okay, we might recall that an integral is just area under a curve. And in particular, it's going to be the area under the curve little f, which was 2x. And the graph of f of x equals 2x is just a line. It has a slope of 2 and a y-intercept of 0. So it would look like this, where this point is 1 and this point is 2. So graphically, that integral should be the area of that triangle. Okay, does the area of that triangle agree with the number 1 that we got down here? Okay, well, if you think about it, it does, because the area of that triangle that we shaded, that's exactly half of the area of this rectangle that I'm drawing. And you can see from the picture that the area of that red rectangle is 2, so the triangle should have an area of 1. So we've just confirmed that the fundamental theorem of calculus gave us the correct value for this integral. Okay, and as we go forward in this section, we'll continue to use this theorem to find exact values of other integrals.